So, greetings. Here we are, folks. I'm going to talk a little bit about circular motion and centripetal forces associated with perhaps other forces we've learned a little bit about this year. For anything to travel in a circular or curved path, we need a force that generates the centripetal force. And for instance, one of the examples we talked about last time we were together, we talked about how friction between the road and the tires of a car is a good example of maybe off an exit ramp or something like that. And in order to do so, we need the frictional force to equal the centripetal force. Now, you may remember that centripetal force and frictional force both have an equation, right? Whereas the frictional force could be expressed as mu Fn, and the centripetal force can be expressed as mv squared over r. Well, what I'd like to do is I'd like to set the two equal to one another and then be able to solve for different variables. So if Fc equals Ff, then I should be able to say mu Fn equals mv squared over r. But further, the normal force, since there are no angles at play, Fn we can say equals Fw. And if you look at your equation page and you think hard to yourself, you'll say, well, Fw is really just mass times gravity. So I could say mu mg equals mv squared over r. Well, once I've made that realization, perhaps I could then cancel my m's, and I could solve for different variables here. And I know mu is one of the popular variables that we solve for, or v is another popular variable we could solve for. If we go through some algebra and we solve this for mu, we could then divide both sides by g, and we could say mu therefore is going to equal v squared over gr. If we wanted to solve for v, then we get that coveted v equals radical rug. And we could solve for either the coefficient of friction required to make the turn, or perhaps the minimum speed that would be necessary if the coefficient of friction was significantly reduced. Thanks.